The summer heat shimmered over the concrete apron at Recklinlerz Airfield on the afternoon of June 15, 1944. Hauptmann Hans-Werner Lersch walked across the tarmac toward a fighter that should not have been there. The aircraft wore German markings now, black crosses on silver skin, yellow identification panels on nose and wings, but everything about its lines spoke of American engineering. This was a North American P-51B Mustang, one of three that had been salvaged from crash sites, patched together with parts from other wrecks, and made airworthy again by the skilled mechanics of the Erprobungskommando, the testing command at Rechlin. Lersch was 31 years old. He had been testing aircraft for the Luftwaffe since 1936, long before the war began. Unlike the young fighter pilots who flew combat missions over the Reich, Lersch's job was to fly everything: German prototypes, experimental designs, and captured enemy aircraft. He had flown Russian Yaks and American Airacobras, British Spitfires and Hurricanes. He approached each machine with the same methodical curiosity, looking for strengths to admire and weaknesses to exploit. But as he circled the P-51B on the ground, something felt different. The aircraft looked purposeful in a way few fighters did. The fuselage was sleek, almost sculpted. The wings were thin and smooth. The big scoop under the belly housed the radiator for the Packard-built Rolls-Royce Merlin engine, the same V12 that powered the Spitfire, but in this application producing 1,520 horsepower for takeoff and 1,720 horsepower at war emergency power. The propeller was a 4-blade Hamilton Standard unit, measuring 11 feet and 2 inches in diameter. Lersch had read the intelligence reports. Since March 1944, P-51 Mustangs had been escorting American bomber formations all the way to Berlin and back. The appearance of these long-range escorts had shocked the Luftwaffe High Command. For years, German fighters had relied on a simple defensive strategy: attack the bombers before their short-range escorts turned back due to fuel limitations. The P-51 had made that strategy obsolete overnight. Now the Reichsluftfahrtministerium, the Reich Aviation Ministry, wanted answers. What made the Mustang so effective? What were its weaknesses? How could German pilots defeat it in combat? Lersch climbed the wing route and lowered himself into the cockpit. His first impression was immediate and striking. Spess. After thousands of hours in German fighters, where the cockpit wrapped around you like a tight glove, where your shoulders pressed against the framework and the cannon breech sat between your knees, the P-51 cockpit felt enormous. The canopy was a clear bubble that gave an unobstructed view in all directions. The instrument panel was well laid out, logically arranged. The seat was adjustable. Even the control stick felt different in his hand, lighter, more responsive. He studied the controls carefully. The throttle quadrant on the left side wall included not just the throttle lever, but also the propeller pitch control and mixture control. A small switch activated the electric starter. No hand cranking of a heavy inertia starter, the way ground crews had to do with the Messerschmitt Bf 109 in cold weather. Just flip the switch and the Merlin fired. Lersch went through the unfamiliar checklist with the help of notes prepared by the technical staff. Battery on, fuel selector to main tank, mixture rich, propeller to high RPM, throttle cracked open 1 inch. Then he flipped the starter switch. The Merlin caught immediately with a deep authoritative roar. The engine note was smoother than the Daimler-Benz engines he knew so well. There was no harsh vibration, no stuttering, just smooth, powerful rotation. He let it warm up, checking oil pressure and coolant temperature. Everything read normal. The tower cleared him for takeoff. Lersch released the brakes and added power. The Mustang accelerated smoothly down the runway. At 90 miles per hour, he eased back on the stick and the fighter lifted cleanly into the air. Gear up, flaps up, climb power, and then Hans-Werner Lersch, who had flown more than 50 different aircraft types in his career, felt something he had not expected: pure, uncomplicated pleasure. The P-51 climbed like it wanted to be in the sky. The controls were beautifully harmonized. Ailerons, elevator, and rudder all required similar stick forces, giving the pilot a natural feel for the aircraft's attitude. The visibility was spectacular. Lersch could see the ground directly below him through the clear panels in the cockpit floor. He could check his 6 o'clock position with just a glance over his shoulder. He leveled off at 10,000 feet and ran through basic handling tests. Gentle turns left and right, steep turns at 60 degrees of bank. Slow flight near the stall. Everything the Mustang did, it did cleanly and predictably. There were no bad habits, no sudden quirks. It was an honest airplane. Lersch pushed the throttle forward and accelerated to 300 miles per hour, then pulled into a maximum performance climb. The Mustang shot upward with authority. At 20,000 feet he leveled off and checked his watch. The climb rate was excellent, better than a Bf-109 G6 at the same altitude. He continued climbing. At 25,000 feet, something changed. The Merlin's two-stage, two-speed supercharger automatically shifted to high blower. Power remained strong and smooth. Lersch kept climbing. At 30,000 feet, where German fighters began to lose performance, the Mustang was still pulling hard. The engine showed no signs of strain. Lersch ran a series of high-speed dives, checking control response and stability. At 400 miles per hour indicated airspeed, the Mustang remained rock-steady. No buffeting, no tendency to tuck under into an uncontrollable dive. The controls stayed effective even as he approached compressibility limits that would have made a Bf-109 shake itself apart. After 90 minutes in the air, Lersch brought the Mustang back to Rechlin and landed. He taxied to the dispersal area, shut down the Merlin, and sat in the cockpit for a long moment thinking. Then he climbed down and walked to the debriefing room, where a group of technical officers was waiting. They wanted his initial assessment. Lersch chose his words carefully. He was a professional test pilot, trained to be objective and thorough. But he was also a German officer, and these men were looking for weaknesses they could exploit in combat. "It is," he said quietly, "a very fine aircraft." The room went silent. "The cockpit visibility is excellent," Lersch continued. "The controls are well harmonized. The engine is smooth and powerful. High-altitude performance is outstanding. I found no handling vices." One of the senior officers leaned forward. "And its weaknesses, Hauptmann Lersch, eh?" Lersch paused. "I will need more flight time to give you a complete evaluation, but I can tell you this much already. If this aircraft has weaknesses, they are not obvious. That was the first shock." Hans Werner Lersch, a man who had spent 8 years finding flaws in aircraft, had just told the Luftwaffe High Command that the enemy's fighter had no obvious defects. The words hung in the air like an unwelcome truth. While Lersch began his systematic test program at Rechlin, combat reports from frontline fighter units were painting a disturbing picture. The P-51 Mustang was not just another Allied fighter to be defeated with superior tactics. It was fundamentally changing the air war over Germany. On March 4, 1944, the US 8th Air Force had launched its first major raid on Berlin. 57 P-51Bs of the 354th, 357th, and 363rd Fighter Groups escorted the bombers all the way to the German capital. Reichsmarschall Hermann Göring, commander of the Luftwaffe, had famously declared that no enemy bomber would ever reach Berlin. Now, American bombers were over the city with long-range fighter escort, and there was nothing the Luftwaffe could do to stop them. The combat losses told the story in brutal numbers. During Big Week, the intense series of bombing raids in February 1944, the Luftwaffe lost 17% of its experienced fighter pilots killed or seriously wounded in just 7 days of combat. These were not replaceable losses. Germany could build Feichts in underground factories scattered across the Reich, but experienced pilots took years to train, and fuel for training flights was growing scarce. The intelligence officers at Rechlin compiled a dossier on the P-51 from combat reports and interrogations of captured American pilots. The picture that emerged was sobering. Range performance was impressive. The P-51B could fly escort missions of up to 850 miles radius with drop tanks, far enough to reach any target in Germany from bases in England. With careful fuel management, some pilots were reporting endurance of 7 hours or more. Speed capabilities were equally remarkable. Maximum speed was recorded at 440 miles per hour at 25,000 feet. The aircraft maintained high speed even at extreme altitudes where German fighters struggled. Armament consisted of 6.5 caliber Browning machine guns, 3 in each wing, with 1,260 rounds total. American pilots were taught to fire in short bursts at close range, making every bullet count. Tactical doctrine was sophisticated. The 8th Air Force fighter groups had developed a formation called Fluid 4, 2 pairs of fighters that could split, reform, and support each other. Mustang pilots were ordered to avoid prolonged turning fights with German fighters. Instead, they used their superior speed and energy retention to dictate the terms of combat. Dive through the formation, fire, zoom back to altitude, repeat. If a German fighter tried to follow them up, the Mustang could simply outclimb them above 25,000 feet. Production numbers were staggering. North American Aviation's factories in California and Texas were producing more than 100 P-51s per week. By war's end, total production would exceed 15,000 aircraft. Germany, hammered by round-the-clock bombing, could not match those numbers. One combat report from Jagdgeschwader 52, the most successful German fighter wing in history, stood out. An Oberleutnant with more than 100 victories had encountered a formation of Mustangs at 28,000 feet while escorting bombers near Vienna. He attempted to engage, but the American fighters simply accelerated away in level flight. When he tried to dive after them, they outdove him and then zoomed back to altitude faster than his Bf-109G could follow. The German pilot's conclusion was blunt. Against this aircraft at high altitude, we have no effective counter. Another report from Jagdgeschwader 3 described an engagement over Brunswick, where a group of Bf-109s attacked a bomber formation. The Mustang escorts responded immediately, diving through the German formation in pairs. Every time a German fighter committed to an attack on the bombers, a pair of Mustangs appeared on his tail. The German pilots were forced to break off their attacks to defend themselves. The bombers continued to their target undisturbed. 0 bombers were shot down. 3 German fighters were lost. This was the new tactical reality. The Luftwaffe could no longer mass its fighters against bomber formations and attack them before the escorts turned back. The escorts were always present, always overhead, always ready to pounce. American fighter groups were rotating through escort duties, ensuring fresh pilots and fresh aircraft on every mission. The 8th Air Force alone had more than 15 fighter groups equipped with P-51s by summer 1944. That was more than 600 Mustangs available for operations at any given time. The fuel consumption data was equally telling. A typical Mustang escort mission to Berlin and back consumed approximately 300 gallons of fuel per aircraft. The 8th Air Force flew hundreds of fighters on every mission. Total fuel consumption for a single large-scale raid could exceed 200,000 gallons. Germany, by contrast, was desperately short of aviation fuel. Production had peaked in 1943 and was now falling due to Allied bombing of synthetic fuel plants. Luftwaffe fighter units were being grounded not because they lacked aircraft, but because they lacked fuel to fly them. Hans-Werner Lersch read these reports in his office at Rechlin and compiled them into a comprehensive analysis. The combat pilots were describing exactly what he had experienced in his test flights. An aircraft that was superior in the kind of war Germany was now being forced to fight. But the reports also revealed something more fundamental. The P-51 was not winning through superior performance in dogfights. It was winning through sustained operational capability, the ability to be over the target every day, with enough fighters to overwhelm defensive responses, flown by pilots who had enough fuel and training to execute their missions effectively. Over the next 3 weeks, Lersch flew the captured P-51B for more than 40 hours, putting it through every test in the Rechlin evaluation protocol. He was joined by Oberleutnant Hans Fay, another experienced test pilot, who flew a second captured Mustang that had been assembled from salvaged parts. The 2 pilots compared notes after each flight, building a comprehensive technical picture. The testing was methodical and exhaustive. Takeoff and landing performance was evaluated first. The P-51B required 1,200 feet of runway for takeoff at combat weight with full internal fuel. Landing speed with full flaps was 90 miles per hour. The aircraft had no bad habits during landing approach, no tendency to drop a wing or balloon. Visibility over the nose during the landing flare was adequate, though not as good as the Focke-Wulf FW-190. Climb performance was impressive. At combat power settings, the Mustang climbed at 3,200 feet per minute from sea level to 10,000 feet. The rate of climb remained above 2,000 feet per minute all the way to 25,000 feet. Above that altitude, when the supercharger shifted to high gear, performance actually improved. Lersch noted in his report, "This aircraft maintains effective combat capability at altitudes where our fighters are struggling to maintain formation. Level speed trials revealed exceptional performance. At 25,000 feet, the P-51B achieved a true airspeed of 440 miles per hour at maximum continuous power. At war emergency power, with water methanol injection for the Merlin engine, speed increased to 455 miles per hour. Even more impressive was cruise speed at economical power settings, 290 miles per hour at 25,000 feet while burning only 50 gallons of fuel per hour. This combination of high cruise speed and low fuel consumption gave the Mustang its extraordinary range. Dive performance testing proved equally revealing. Lersch pushed the Mustang into vertical dives from 30,000 feet, carefully monitoring indicated airspeed and control effectiveness. The aircraft remained stable and controllable past 0.78 Mach number, well beyond the point where a BFR-9 would encounter severe compressibility buffeting and loss of elevator authority. The laminar flow wing designed by North American Aviation in cooperation with NACA, the National Advisory Committee for Aeronautics, kept airflow smooth over the wing surface at higher speeds than conventional airfoils. This gave the P-51 a critical advantage in high-speed combat. It could dive faster, recover sooner, and zoom back to altitude before German fighters could react. Turn performance was the one area where German fighters still held an advantage. At speeds below 250 miles per hour and altitudes below 15,000 feet, the Bf-109G could outturn the Mustang. The 109's leading-edge slats deployed automatically near the stall, giving it a tighter turning radius. The FW-190A was even better in the rolling scissors maneuver. But Lersch noted a crucial tactical point in his report. The P-51 pilot need never accept a slow-speed turning engagement. He can simply add power and accelerate away. Our fighters cannot follow. This means the American pilot decides when and where the combat occurs. We can only fight on his terms. Endurance and range testing revealed the Mustang's true strategic advantage. With internal fuel only, 184 gallons in fuselage tanks, the P-51B had a range of 950 miles. With two 75-gallon drop tanks, range extended to 1,300 op tanks. With two 100 load for Berlin escort missions, range reached 1,650 miles with reserves. Total fuel capacity with external tanks was 400 gallons. At economical cruise settings, this gave the Mustang an endurance of more than 7 hours. Lersch flew a simulated escort mission profile to verify these numbers. He took off with two 108-gallon drop tanks, climbed to 25,000 feet, cruised at 290 miles per hour for 600 miles, conducted a simulated 20-minute combat engagement at high power, then cruised back to base. When he landed, the fuel gauge showed 50 gallons remaining, enough for another hour of flight. The Bf-109G6 by comparison had a total fuel capacity of only 88 gallons. Combat endurance at high altitude was approximately 80 minutes. With a single 300-litre drop tank, endurance increased to perhaps 2 hours. The difference was staggering. A Mustang could fly for 7 hours. A 109 could fly for less than 90 minutes. This is not a difference in performance, Lersch wrote in his report. This is a difference in strategic capability. The P-51 is not merely escorting bombers to the target. It is ending our ability to choose when the battle will be fought. Hans Fay, Lersch's fellow test pilot, had a background in mechanical engineering before the war. He spent hours examining the Mustang on the ground, studying its construction and systems. What he found was as revealing as the flight test data. The Packard-built Merlin engine was a masterpiece of manufacturing precision. Every cylinder produced exactly the same power output. The tolerances on moving parts were so tight that oil consumption was minimal. In 3 weeks of intensive flying, the engine never showed an oil leak, something unheard of in German fighters, where oil streaks on the cowling were normal. The electrical system was equally impressive. The Mustang used a 24-volt system with a generator that could power all electrical loads, radios, gun sight, landing lights, flaps, trim tabs, without dimming or fluctuating. The battery was large enough to start the engine even in cold weather. German fighters still used 12-volt systems that struggled in winter conditions. Even small details showed superior engineering. The fuel tanks were self-sealing, multiple layers of rubber and fabric that automatically closed bullet holes. The cockpit was heated and well ventilated. The canopy had an emergency jettison mechanism that worked reliably. The landing gear was robust and could absorb hard landings without damage. Fay reported his findings to the technical staff at Rechlin. This aircraft was designed for mass production and ease of maintenance. American factories are building these machines with a level of quality control that our factories cannot match under current conditions. Every part is interchangeable, every system is standardized. This is industrial warfare, and they are winning it. The manufacturing quality difference was not just theoretical. Germany was under sustained bombing attack. Factories were dispersed into tunnels and forests. Skilled workers were drafted into military service. Raw materials were scarce. Quality control suffered. The gap between German and American industrial capacity was becoming unbridgeable. One evening in late June, Lersch and Fay sat in the officers' mess at Rechlin, discussing what they had learned. The conversation was frank in a way that would have been dangerous if overheard by the wrong people. "How many of these machines are the Americans building?" Fay asked. "Intelligence estimates more than 100 per week," Lersch replied. "North American aviation has 2 factories running 3 shifts per day. The plant in Inglewood, California, and the one in Dallas, Texas. Packard is building the engines by the thousands at their Detroit facility. By the end of the year, there could be 2,000 P-51s in service with the 8th and 9th Air Forces alone." Fay shook his head. "We cannot match those numbers. Even if we could, we don't have the fuel to fly them or the pilots to man them. Did you see the training report from OKL last week? Replacement pilots are entering combat with less than 100 hours of total flight time. Some of them have barely 20 hours in the Bf-109 before they are sent to operational units. The Americans are giving their pilots 400 hours or more before they see combat. Many of their fighter pilots have additional training in fighter tactics at specialized schools." "I know," Lersch said quietly. "I flew against a Mustang formation last month during a test intercept exercise. We sent up 4 FW-190s from Rechlin to simulate a defensive engagement. The American pilots, they were from the 357th Fighter Group on a navigation training flight, flew perfect formation. Their tactics were textbook. They covered each other, maintained altitude advantage, and never gave us an opening. When we tried to bounce them, they simply accelerated away. Our experienced test pilots could not catch them. These were not even combat veterans, just well-trained pilots flying a superior aircraft with excellent tactical discipline." The conversation paused as both men considered the implications. Fay broke the silence. "Have you heard the latest production figures for our fighters? The ministry is claiming we built 25,000 aircraft last year. But how many of those actually made it to operational units? How many were destroyed on the ground by Allied fighter bombers before they ever flew a combat mission? How many were written off due to training accidents by inexperienced pilots? The numbers are meaningless when we cannot stay in operations." Lersch nodded. "And even when our aircraft reach the front, they are outnumbered. Last week an intelligence report showed that on a typical large-scale raid, the 8th Air Force puts up 800 heavy bombers with 300 escort fighters. We can scramble perhaps 150 to 200 fighters to intercept. Even if every one of our pilots were an ace, which they are not, the mathematics are against us." The mathematics of the air war had become brutal and simple. Germany was losing experienced pilots faster than they could be replaced. During the first 4 months of 1944, the Luftwaffe lost more than 1,000 fighter pilots killed. These were irreplaceable losses. The pilots who survived were exhausted, flying multiple missions per day, often in aircraft that were poorly maintained due to parts shortages and lack of ground crew. Fay leaned back in his chair. "What will you tell them?" "When you submit your final report." Lersch thought for a moment. "I will tell them the truth. The P-51 is not invincible. In a slow-speed turning fight at low altitude, a good pilot in a 109 can still shoot one down. I have no doubt that our aces will claim Mustang victories, but tactical success does not equal strategic victory. The P-51 is winning the war not because it is perfect, but because there are thousands of them. They can fight anywhere over Germany, and they are flown by well-trained pilots who have fuel to spare." "They won't want to hear that," Fay observed. "No," Lersch agreed, "but it is still the truth." On July 3, 1944, Hans-Werner Lersch was summoned to a high-level briefing in Berlin. He carried with him a thick folder containing his complete test report on the P-51B Mustang, 40 pages of technical data, performance charts, and tactical analysis. He had spent 3 days writing it, choosing every word carefully. This was not a political document, it was a technical evaluation, but he knew the conclusions would not be welcomed. The briefing room was in the Reichsluftfahrtministerium building on Leipziger Straße. Sitting around the table were representatives from the technical office, the operations staff, and the fighter command. At the head of the table sat General Oberst Günther Korten, Chief of the Luftwaffe, General Staff. Lerch stood and delivered his report in a clear, unemotional voice. He presented the facts systematically. The North American P-51B Mustang is a highly effective long-range escort fighter, he began. Its performance characteristics are as follows. He outlined the maximum speed first, 440 miles per hour at 25,000 feet. This exceeded the maximum speed of the Bf-109G6 by approximately 45 miles per hour at the same altitude. Climb rate was superior to German fighters above 20,000 feet due to the effectiveness of the two-stage supercharger. Dive performance was excellent. The aircraft remained stable and controllable at speeds where German fighters encountered compressibility problems. Range capabilities with external fuel tanks gave an operational radius exceeding 850 miles. This allowed the P-51 to escort bomber formations to any target in Germany and return to base. Endurance was 7 hours with external tanks. This compared to approximately 80 minutes for the Bf-109G6 with internal fuel. Armament consisted of 6.50 caliber machine guns, effective though not as destructive as German 20mm and 30mm cannon. Handling qualities were excellent. No dangerous flight characteristics had been noted. Controls were well harmonized and effective at all speeds. The only weakness identified, the P-51B could be outturned by the Bf-109G at low speeds and low altitudes. However, American tactical doctrine instructed their pilots to avoid slow-speed turning engagements. They used superior speed and altitude performance to dictate combat terms. Lerch paused and looked around the room. Every face was focused on him. My conclusion is that the P-51 Mustang represents a new generation of fighter aircraft. It was designed specifically for the long-range escort mission, and it performs that mission exceptionally well. Our current fighter tactics, which rely on engaging bomber formations before the escorts turn back, are no longer effective. The escorts are not turning back. The room remained silent for a long moment. Then Korten spoke. Hauptmann Lerch, you are telling us that we have no effective counter to this aircraft. That is not what I am saying, Herr General Oberst. Our fighters can still defeat the P-51 in combat. Our experienced pilots have the skills to do so. But we cannot defeat them strategically. There are too many of them, they have too much range, and they are being produced too quickly for us to match. Unless we can develop a fighter with similar or better performance and produce it in similar numbers, the air war over Germany will continue to favor the enemy. Another officer spoke up. What about our new fighters? The Me-262 jet fighter, the Ta-152 high-altitude interceptor. The Me-262 shows great promise, Lerch replied carefully. I have flown the prototypes. The speed is remarkable, 540 miles per hour in level flight. Against that kind of performance, the P-51 would be at a severe disadvantage, but the Me-262 is not yet in production in meaningful numbers. The engines are unreliable and have very short service lives. The aircraft requires a long, smooth runway for takeoff and landing, making it vulnerable to fighter-bomber attacks on airfields. Most critically, we do not have the fuel to operate jet aircraft in large numbers. He paused, choosing his next words with care. The Ta-152 is an excellent high-altitude interceptor. At 45,000 feet, it outperforms everything the Allies have. But again, we are building them in small numbers, dozens, not thousands, and the bomber formations are operating at 25,000 to 30,000 feet, where the P-51 has performance advantages over our current fighters. We need a fighter that can be mass-produced, that can operate from damaged airfields, that can be maintained with limited spare parts, and that can be flown by pilots with minimal training. Herr General Oberst, with respect, this is no longer a problem that can be solved by superior aircraft design. This is an industrial and logistical problem. Korten leaned back in his chair, his face grave. So you are telling us that unless we can match American industrial production, we have no path to victory in the air. I am telling you that the strategic situation has fundamentally changed, Lerch replied. 6 months ago we could still contest air superiority over Germany. We could choose when and where to commit our fighters. We could wait for favorable tactical conditions. The P-51 has eliminated those options. Now the enemy decides when the battle will be fought, and they have the numbers and endurance to fight every day. Our defensive strategy relied on the escorts turning back. The escorts are not turning back." Another officer interjected, "But our pilots are still achieving victories. Major Hartmann of JG-52 has over 200 kills. Oberst Barkhorn has nearly as many. Surely individual skill still matters?" "Of course it matters," Lecher said. "And yes, our best pilots will continue to shoot down Allied aircraft, including Mustangs. But consider the mathematics. If Major Hartmann shoots down 5 Mustangs in a single day, a remarkable achievement, the Americans will replace those 5 aircraft within 24 hours. The pilots may take longer to replace, but they have a training system that produces thousands of competent fighter pilots. We are losing 100 pilots per week, and our training schools can produce perhaps 30 replacements in the same period. This is a war of attrition, and attrition favors the side with greater resources." The briefing ended shortly afterward. The officers thanked Lersch for his thoroughness and dismissed him. He left the building and walked out into the summer sunshine, feeling the weight of what he had just done. He had told the Luftwaffe High Command that Germany was losing the air war, and he had shown them the machine that was winning it. 3 weeks later, on July 25, 1944, Hans-Werner Lercher was back at Rechlin when word came down from Berlin. Reichsmarschall Hermann Göring had made a statement during a conference with fighter commanders that was already spreading through the Luftwaffe like wildfire. "When I saw Mustangs over Berlin," Göring had said, "I knew the jig was up." The Reichsmarschall, the man who had promised that no enemy bomber would ever reach the capital, had admitted the truth that Lercher's report had documented with cold precision. The P-51 Mustang had ended the Luftwaffe's air superiority over Germany. The strategic implications were devastating. Without control of the air, German industrial production would continue to be hammered by Allied bombing. Without fuel, the Luftwaffe could not train new pilots or fly combat missions. Without experienced pilots, the few remaining fighters would be ineffective. The spiral was irreversible. Lersch understood all of this. He had seen it in the numbers, in the engineering quality, in the simple fact that the P-51 could fly for 7 hours while the Bf-109 could barely stay airborne for 90 minutes. The war in the air was already over. Everything that followed would be a slow, grinding conclusion. But German pilots would keep fighting. Aces like Erich Hartmann, Gerhard Barkhorn, and Günther Rall would continue to shoot down Allied aircraft, including Mustangs. The final victory totals for Luftwaffe aces would reach numbers that seem impossible today. Hartmann with 352 victories, Barkhorn with 301, Rall with 275. But individual skill could no longer change the outcome. The P-51 Mustang would claim 4,950 enemy aircraft destroyed by the end of the war. More than 15,000 Mustangs would be built in total, with over 8,300 of them being the improved P-51D model with bubble canopy and 6 guns. The aircraft would serve not just with the US Army Air Forces, but with the Royal Air Force, the Royal Canadian Air Force, the Royal Australian Air Force, and many other Allied nations. After the war, it would fly combat missions in Korea and remain in military service with some countries into the 1980s. Hans-Werner Lersch survived the war. In April 1945, as Allied forces closed in on Rechlin, he destroyed his test notes to prevent them from falling into enemy hands. He was captured by British forces and spent 2 years in PRB camps, where he was extensively interrogated about German aircraft development. The British and Americans were particularly interested in his reports on captured Allied aircraft. After his release in 1947, Lersch returned to aviation. He became a test pilot for the new West German aircraft industry, helping to rebuild the nation's aerospace capabilities. He also wrote extensively about his wartime experiences, publishing detailed technical memoirs that became valuable historical sources. In his later writings, Lersch reflected on the P-51 Mustang and what it represented. The P-51 was not the best fighter aircraft of the war in every single performance category, he wrote. The Focke-Wulf TAR-152H had better high-altitude performance. The Me-262 was faster. The Spitfire had better visibility. But the P-51 was the most effective fighter because it combined good performance in all areas with exceptional range, reliability, and ease of production. It was the right aircraft at the right time, built by a nation that had the industrial capacity to produce it in decisive numbers. He continued, "When I first flew the captured P-51B at Rechlin in June 1944, I knew immediately that this was a machine our industry could not match under wartime conditions. The quality of engineering, the precision of manufacturing, the thoughtful design of every system, these things spoke of an industrial base that was intact, well supplied, and operating at full capacity. Germany, by contrast, was being bombed around the clock. Our factories were scattered and hidden. Our skilled workers were at the front. Our fuel was running out. I reported these facts to my superiors because it was my duty to tell them the truth. The truth was uncomfortable, but it was necessary. The P-51 Mustang did not win the war by itself, but it was the instrument that made victory possible by destroying the Luftwaffe's ability to defend German airspace. Without that capability, everything else followed inevitably." Hans Werner Lersch died on August 14, 2007, at the age of 94. He remained an active pilot until his 70s, still testing aircraft and sharing his knowledge with younger generations. His wartime test reports are now preserved in archives in Germany, England, and the United States, valued as some of the most objective technical assessments of combat aircraft ever written. The story of Hans Werner Lersch testing the P-51 Mustang is not a story about one pilot or one aircraft. It is a story about industrial capacities, strategic warfare. By the end of World War II, the numbers told the complete story. 51 Mustang production totaled 50 Mustang 6 aircraft. This included 3D Outs, 738 P-51B and C models, 8001-2 P-51D models, 1037 P-51K models, and 2409 other variants. Luftwaffe fighter production in 1944 reached approximately 25,000 aircraft, but losses in combat totaled approximately 21,000 aircraft in the same period. The net gain was insufficient to maintain operational strength. Pilot losses told an even grimmer story. The Luftwaffe lost 2,262 fighter pilots killed in 1944 alone. The USAF lost 2,590 fighter pilots killed in the entire European theater throughout the war. Training time showed the quality gap. Luftwaffe replacement pilots averaged 100 hours of flight time before combat. USAF pilots averaged 400 hours or more. The P-51 Mustang cost approximately $50,000 to build in 1944, roughly $800,000 in today's dollars. North American Aviation produced them at a rate of more than 100 per week at peak production. The Packard Motor Company built the Merlin engines at a factory in Detroit, producing 55,000 engines during the war years. Against this industrial tsunami, Germany could not compete. The Bf-109 was an excellent fighter when it first flew in 1935, but by 1944 it was obsolete, outperformed by Allied fighters at high altitude and unable to match the range and endurance required for modern air combat. The FW-190 was better, but still could not escort bombers to Berlin and back. The Me-262 jet fighter, when it finally entered service in 1944, was technologically superior to anything the Allies had. But Germany built only 1,433 of them, and most never flew combat missions due to lack of fuel, lack of trained pilots, and lack of spare parts. Technology alone could not overcome industrial collapse. Hans Werner Lersch understood this in June 1944 when he climbed down from the cockpit of the captured P-51B and told his superiors it was a very fine aircraft. He had seen the future, and the future was not determined by individual skill or tactical brilliance. It was determined by factories, fuel supplies, training programs, and the ability to produce thousands of effective aircraft flown by well-trained pilots. The P-51 Mustang was the physical embodiment of American industrial power applied to the problem of air superiority. It worked, and once it entered service in numbers, the outcome of the air war over Germany was no longer in doubt. Today, hundreds of P-51 Mustangs still fly at air shows around the world. Restored to pristine condition by dedicated enthusiasts, they roar through the sky with the same distinctive Merlin sound that once signaled the end of the Luftwaffe's dominance. These aircraft are now valued at several $1 million each, prized as flying pieces of history. At every air show where a P-51 appears, crowds gather to watch. The aircraft is still beautiful, still purposeful, still impressive 80 years after it first flew. Old veterans who flew them in combat sometimes sit in the crowd, remembering. Some of them remember friends who never came home. Others remember the cold at 30,000 feet, the fear of flak, the sudden violence of air combat. But they all remember the aircraft itself, the machine that could fly for 7 hours, fight for 30 minutes, and still bring them home. The machine that had room to think, room to fight, room to endure. Hans Werner Lersch, in his memoirs, wrote one final assessment of the P-51 Mustang. It was not invincible, but it was good enough, built in numbers large enough, and operated by pilots trained well enough to accomplish its mission. That is all any weapon of war needs to be. The rest is mathematics. The mathematics spoke clearly in 1944, and the silver fighter with the deep Merlin roar was the equation that changed history.